Hello, let's use some rules of logarithm and indices in solving this nice Olympiad exam math question. We're asked to solve for y in 4 to the power of x multiplied by 4 to the power of x multiplied by 4 to the power of x equal to 20. Don't forget to give this video a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified maths content. Now we're going to solve using laws of indices and logarithm. To get started, I want you to recall this law of indices that if I have a multiplied by x, a to the power of x multiplied by a to the power of y, and this can be equal to a to the power of x plus y, right? So if we apply it over here for all this, we're going to have that expression to now give us 4 to the power of x plus x plus x, and this will be equal to 20. Great. Now 4 to the power of x plus x plus x is equal to 20. X plus x plus x is going to give us 4 to the power of 3x, right? And this will be equal to 20. Now we can have 2 to the power of 2 or to the power of 3x. Now can we have this to give us 2 to a power as a base? 22 to a power, no. And so as a result of that, the only way we can break down this is the use of indices or with the use of logarithm. We either use logarithm, the natural logarithm, or we use the rules of logarithm. Now, if we apply logarithm, we are going to have this to become the log of 4 to the power of 3x equal to the log of 20. Now, taking these two parts, we are going to see that according to the law of logarithm, this is going to multiply this log. And then this will give us 3x multiplying the log of 4, which is equal to the log of 20 can be equal to log of 4 multiplied by 5, right? Great. Now, looking at that expression, we can recall a given law of logarithm that if we have this expression like this, we can simply find the value of 3x because this can divide log of 4. If we divide both sides by the log of 4, and then divide here also by the log of 4, you simply see that the log of 4 will cancel out the log of 4, and then we'll be left with 3x, right? So we'll have our 3x to be equal to the log of 4 multiplied by 5, and that will be divided by the log of 4. Great. Now from this expression, we can see that we can simplify. Now recall the law of logarithm, multiplication law of logarithm, that we will have log of xy. Log of xy can be equal to the log of x, right, plus the log of y. Now if we have these two logarithm expression, we can use it to replace the numerator of that fraction. So we'll have our 3x to be equal to the log of 4 plus the log of 5, and all of these can be divided by log of 4. Great. Now in the next step, I can separate this fraction. If I separate that fraction, I'll have my 3x to be equal to the log of 4. This time around, we divide the log of 4, right? And this will be plus the log of 5 divided by the log of 4. So from this, the log of 4 can cancel out the log of 4, and such, we'll have that expression to now give us 3x, right, equal to 1 plus log of 5 divided by the log of 4. Great. Now at this point, what do we do in order to simplify this expression? At this point, all we simply need to do is to recall a given law of logarithm. Now, if you recall that law of logarithm, from that law of logarithm, we can simplify that logarithm fraction. If we have the log of a dividing the log of b, according to the rule of logarithm, this can be equal to the log of a base b, right? The denominator becomes the base and the numerator becomes the log. Now, in the next step, if we apply it in the next step, we are going to have that logarithm expression to now be equal to, this is 3x equal to 1 plus log 5. That will give us the log of 5 base what? Base 4. Great. Now, if we have the log of 5 base 4, the next step, we can find the value of x. The value of x can be found if we divide both sides by 3. So if we divide both sides by 3, 3 cancel out 3, and then the value of our x can be equal to 1 plus log of 5 base 4 divided by 3. And this becomes the solution we are actually looking for. Great. Now check out this solution and then let's see if we check if the solution is actually right. We have 4 to the power of x multiplied by 4 to the power of x multiplied by 4 to the power of x equal to 20. Now recall that 4 to the power of x plus x give us 4 to the power of 3x equal to 20. Now, if we take that expression from that point, we're going to have that expression to now give us 4 to the power of 3x, right, equal to 20. So, if x is equal to the expression 1 plus log of 5 base 4 divided by 3, then we can have that expression to be 4 to the power of 3 multiplied by 1 plus log of 5 base 4 divided by 3, and all of this, is it going to give us 20? That's a big question. Now, let's look at that. From that expression, 3 can cancel out 3, right? And then we'll be left with 4 to the power of 1 plus log of 5 base 4. Will this give us 20? Now recall this algebraic expression or this indices that if you have a to the power of x plus y, that this can be equal to a to the power of x multiplied by a to the power of y, right? So if we apply it for this this expression, we're going to have that to now become 4 to the power of 1 multiplied by 4 to the power of log of 5 base 4. Is it going to give us 20? From your mind's eyes, you can start seeing that this can give us 20. If you recall the law of logarithm, that if you have x to the power of log of a base x, that this can be equal to a, because x can cancel out what? X. So same thing goes with this. If 4 cancel out 4, that will be left with 5. So the log of 4 to the power, the value of 4 to the power of log of 5 base 4 can be equal to 5. So we'll have 4 multiplied by 5, will it equal to 20? Of course, 4 times 5 is 20. So 20 is equal to 20. So that tells us that the value of x equal to 1 plus log of 5 base 4 divided by 3 is the solution that satisfies that expression given to us up there. You see? Now, I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified maths content. Thanks so much for watching, and bye-bye for now.